Right, the last problem of tutorial 2, and I'm determined to make this video short. So luckily this is an easy problem. Let's see. It says write a program artwork.java that plots 3 functions on a 512 by 512 pixel instance. Sorry, 512 by 512 pixel instance of the draw class. The functions specify the red, green and blue value of the pixels at coordinate x and y respectively. So here are the functions, and it says the values of x and y should range from -1 to +1. So I can already see that, I mean, our biggest issue here is that we want this size canvas, but x should go from -1 to +1. But I think I've got a trick to do that. And then it gives us the 3 functions that each of these pixel values should have. So if I just pick a random pixel here, its red value should be this, green this, blue this, for the appropriate x and y. And we should end up with something that looks like this. So step 1 will be to just start with the outline. Let me just close this up. This is our previous exercise. I'm going to make a new Java package called artwork, and I'll create a new Java class called artwork. Right, and we need a main function, and inside we need to draw. It says an instance of the draw class. So we've been using standard draw dot set canvas size, and let's see, 512 by 512, and this is fine and this will work. But I just realized that the question asks for an instance of the draw class. So just like there is a standard in, but there's also an in class that standard in is one class, and I can call it static methods, but I can create multiple instances of that class using in. And then there is standard out, and I can create multiple instances with class out. And there is standard draw, and I can actually create multiple instances. So to be honest, in this question, I don't think this will make a difference, but let's do it that way since that's what they asked for. So I'm going to say draw, and I guess I have to import that. Drawing, I'll just call it drawing, is a new draw. And what are the constructor options? There's no documentation in this class. That's a pity, but I wonder if there's no. It seems I just do that. Okay, that's a new drawing. Then can I say set canvas size and all that stuff? Let's look at the routines available. I can say main. You know, I think I'm doing this wrong. How are we going to figure this out? Well, we could have a look at the textbook, I guess. But I don't think that's the way to go. Well, I'll tell you what, let's use standard draw, and then I'll have a quick scan of the textbook, and we'll see if how to change it to an instance of draw. It should be 512 and 512. And the other thing I usually do is to say set x range, x scale, sorry, and min and max. So the trick I'm going to use is to say that I don't care what min and max is, because I'm not going to use them at all. Now usually I would. If I wanted to say draw a line, I'd have to give the coordinates in terms of x0, y0, x1, y1, and they should be in the X scale and Y scale for this the drawing I'm doing. But there is another routine called pixel, get pixel, set pixel. And these coordinates are not, if well, let's do that quickly. Draw set X scale 0 to 1, and the same for Y. Now if I want to draw a line or a rectangle, whatever, I would use a value between 0 and 1, from 0.2 to 0.7 and 0.8. So this is a line on this in these coordinates. But when I use set pixel, the XY coordinates is not from 0 to 1, but they're from 0 to 511, and Y is 0 to 511. So here I can actually set the individual pixels to a certain color. This is the method I want to use. So these routines at the top have no appeal to me. I mean, I'm not going to use them. Okay, let's go for this. X starts at 0, X goes to 511, X plus plus. Y goes from 0, Y is less than 511, Y plus plus. Right. And now I need to convert X and Y, which are now from 0 to 511. I need to convert those to values from -1 to +1. And the way I'm going to do that is to say, well, I am going to divide X by 256. So I'm going to create a double XX, that is X divided by 256.0. So let's see. If X starts at 0, then this XX will be 0. So let's write down the ranges. X goes from 0 to 511. XX, if X is 0, XX is also 0, because 0 divided by 256 is 0. But it goes, when X is 511, that's almost double 256. So this will be almost 2, 1.999. But let's call it 2. So now XX goes from 0 to 2, and if I subtract 1, it will go from, if I subtract 1 from 0, I get -1. If I subtract 1 from 2, I get 1. So if I add a -1 here, I've now converted X to double X. X goes from 0 to 511. Double X goes from -1 to +1. And that's exactly what the question is asking. So this is what I'm going to do. I'm going to do exactly the same thing for Y. So X and Y are the coordinates in the 512 by 512 coordinate system. Double X and double Y are coordinates from -1 to +1. I need those because I need to calculate these functions using values that are in that range. So I'm going to copy and paste the functions right here. Okay. So red, which I guess will be, let's make it a double for now. Red of a certain coordinate is this very complicated formula. As you can see, it's quite long. And it uses X and Y, but those should be XX and YY. Let's just find all of them. There's a YY. Is there anything else? No. Right, I don't like this formula, plus there's a lot of mistakes in it. For example, I can't say math, I have to say math.sine. Sorry, I can't say sine, I have to say math.sine. This video is getting too long. Okay, but my quick solution for that is to say I'm going to define my own function that I'm going to call S, a nice short name. And it's going to take some double value, A, and it's going to return math.sign of, come on Java, come on Eclipse, math.pi times A. So instead of writing sine of pi times that story, this function will just turn into S of whatever comes after the pi. And again, this S sine of pi times something will turn into that. Again, and again. And again, this is a complicated function. And again, okay, here we have cosine. So I'm going to write a similar function for cosine. I'll call it C. I'm just going to calculate the cosine of pi times something. Okay, right, here we go. Let's just see if these brackets match up. This closes the highlighted bracket, this closes that bracket, that closes that bracket. I think a few are missing, but they're still coming. Okay, let's just carry on with this. Sine becomes that, cos becomes that. Here is average of two values. I'm going to write a function for that. I'll just call it A, so it's nice and short, and it'll take a B and a C, and it will return A plus B, B plus C times 2.0. There we go. So average just becomes A, sine of that, and I think the rest can stay. Too many brackets. Okay, let's do that one by one. I don't need to bracket around x times x. So that closes average, cosine, sine, cosine. And do I still need a bracket? Yes, 2, 3. And I think if I take this out, everything is correct. Right. So this isn't too complicated. It's just a little trick to make things a little clearer. Okay, right. And now double G is much easier. This is just S of double X. And blue, double B, is the cosine. Oh, but this time there wasn't a pi times something. I think that's a mistake. I think it's missing from the question. We'll see if my artwork turns out. Is this correct? Okay, right. So we've got the RGB. It's the sine of some value, and as we know, sine sends back a value from -1 to +1, as does cosine. So we have to convert these values back up to integers that lie from 0 to 255, because that is what we're going to use next. So color C is, I don't have an important color. Let's do import color. Is a new color. Let's see what and I can give it floats. Oh, but this is wonderful. But I have to be careful because these floats have to be from 0 to 1. And I can see here at the bottom, let me move this up so you can see it too. There is a constructor. So I'm sorry about that. I wanted to press that. Here are all the constructors. There are many constructors, ways of making a new color. but one of them takes floats. But as they explain, I still don't think you can see it. This explanation says this will throw an exception, an error, if R, G or B are outside of 0 to 1. So at the moment, R, G and B are from -1 to +1. So I'm going to do the reverse of what I did up here. I'm going to take R and I'm going to add 1. Now it's not from -1 to +1, but from 0 to 2. And I'm going to divide that by 2. I think this is correct. I hope so. We'll see. R, G, and B. What is it complaining about? Oh, they're doubles and not floats. Okay, let's make them floats. Copy that. And now the problem is that these functions are sending back. Of course, Eclipse has search and replace, and I should be using that. But, oh, and this sends back a double. Oh, what do we do? I tell you what we do. We undo all these changes that I've made, and right here we do the cast to a float. Look, these values are going to be between 0 and 1. The difference between double and float is firstly in the precision. So doubles are more precise than floats, but for our purposes, the human eye can't make that finer distinction between colors. And the other difference is that doubles can store very large numbers, floats can store smaller numbers. So, but we're not going to worry about that because our values are all between 0 and 1. I'm running out of time. What did I call it? Oh, no, I didn't call it anything. I said standard raw.show. Okay, I think that's it. So let's just revise. We created the canvas of the appropriate size, and we looked at all its pixels because we want to set each and every pixel. For each of those pixels, I converted the x and y coordinates to double x and double y, which are from -1 to +1. Then I copied and pasted the formulas, and I made them a little shorter by implementing my own version of these sine, cosine, and average functions. These names are not very descriptive, and maybe I should add an explanation, but on the other hand, if you look at it, you can see, S is just calculating math.sine. Right, then I used this fancy constructor for a color to get a new color, and I put the pixel there. Let's see what happens. Let's run artwork. See what we get, if we get anything. Oh, interesting. I mean, this is very interesting. This is correct, but many things are wrong. This video continues for another 10 minutes with me struggling to fix the problem with this program because it doesn't look like the tutorial page says it must. But I've looked through all my old programs, and it turns out I probably generated this picture using a very different formula that I simply cannot get back. And this is correct based on this formula. It is similar to this, even if it's not exactly the same. I thought about experimenting with different formulas here to give you some idea of what you can do, but I'll leave that for you to do on your own. I think this is close enough and good enough for this tutorial.